Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, let's take a look at our homework for lesson 6.2.4. Looking at problem number 80, it says on your paper, sketch the graph with the right. Okay, so it says write directions for translating the original triangle to make the new one. So here was the original, here's the new. So the fact that it's not being reoriented means all we have to do is do a translation. So if you chose to do the words, I don't know why I've been doing it coordinate notation, but if you chose to do the words, you can do it like this, or I guess the way that we've been doing it. Hold on for a second. Let me get this right. There we go. So X, Y changes such that I guess X would have to go to the left 2, right? So that would be X minus 2, and Y would have to go up 1, 2, so that would be Y plus 2. So you could have written it using the coordinate notation. Let me get this a little less sloppy here. Minus 2, Y plus 2, or just using the words 2 units to the left, 2 units up. Then what is the coordinates of the vertices of the new shape? So this one right here is at negative 3, 3. This is at negative 2, 2, and that's at negative 3, 1. And then it says on your graph, reflect the original triangle over the y-axis. So each one of these points, you end up having the, I guess if it's going over the y-axis, the x-axis is, no. The x coordinates will change to their opposites, but the y's would stay the same. But then they never asked us to write down that anyway. So I guess think of it this way. Here's the line of reflection. So every point, however many units it takes to get there, goes across. So this point right there is at 1, 1, 1. That's at 1, negative 1. And this is 0, 0. Hannah thinks the solution of the system for these two equations is negative 4, 6, negative 6. Wirt thinks it's 2010. Who's correct? Okay, so it looks like the fact that both of them are correct is probably because these two equations are the exact same equations. They're going to be the exact same lines, so anything that works for one is going to work for the other. So the way to figure that out is let's go ahead and solve both of them and put them into slope-intercept form. So this first one is 2x minus 3y is equal to 10. Let me go ahead and write this down here. 2x minus 3y is equal to 10. So I would move the 2x's to the other side, and then it becomes negative 2x's, right? Because you take it away from there. But then you're going to have to add the negative 2x's over here. So it's going to be negative 2x plus 10 is equal to negative 3y. And then when you divide everything by negative 3, these are just very sloppy equations, but whatever. You end up with 1y. Negative divided by negative gives you positive, so that becomes 2/3 of x. And then 10 divided by negative 3, let's just call that negative 10 over 3. Okay, so that's the slope is 2/3, and the y-intercept is at negative 10/3. Let's see this one. You've got 6y is equal to 4x minus 20. So when we divide everything by 6, you're going to get 1y, you're going to get 2/3 of x, and you're going to get negative 10 over 3. So yes, they are the exact same line, same slope, same y-intercept. So either one of the solutions should work. Now, another way you could have tested it is this. You could have plugged in these values for x and y and seen that this ends up being equal to negative 8. This ends up being equal to positive 18, and that equals 10. So it definitely works for this one. And then you plug it in here, and you would see that both of them would work. But that doesn't really explain why both of them work. Why would you have two solutions to the system? Remembering that the solution to the system is supposed to be where the two lines intersect each other. But if you've got two lines, which are actually one line because they're both the same line, then every single point on that line is going to be a solution to both of them. So clearly, both of these points are on that line. All right, tile or figure 2 of a tile pattern is shown at the right. So I put that piece of information, stop it. I put that piece of information right there, okay? 6 tiles for figure 2. Then it says if the pattern grows linearly, which means it grows at a constant rate, figure 6 will have 18. So find the rule for the pattern. All right, I'm going to do this a little bit differently. I'm going to do this completely algebraically without using the table. And then I'll use the table in a second. If we need to find the slope ratio is going to be the change in y over the change in x. So from 6 to 18, that increases by 12. To go from 2 to 6, that increases by 4. So that means that the slope ratio is going to be 3. So m is equal to 3. And now what we're going to do is we're going to say if y equals mx plus b, I'm going to take one of these points. I'll take this one right here, where this is the x value, this is the y value, and this is m, and I'm going to plug those in. So 6 is going to be equal to 2 times 3, which is 6, plus b. So what does b have to be equal to? B has to be equal to 0. And so in y equals mx plus b, if we're going to say y is equal to m is equal to 3, and b is equal to 0, we're not going to bother putting the 0 on there. We're just going to call it y equals 3x. Okay, so that's how we would solve all of this algebraically without creating a table. But if we did create the table, we would say, all right, it goes, to go from here to here, it goes 1, 2, 3, 4 steps. And it takes, what does it go up? It goes up 12 in 4 steps. So how much are they going each step? They must be increasing by 3. So this would be 9. This would be 12. This would be 15. And that is 18. So that is correct. So let's work our way backwards to get to our y-intercept. This would be 3. This would be 0. So I guess this one technically was probably faster than doing it algebraically. But if you had a really gnarly y-intercept and a really gnarly slope ratio, the algebraic way would allow you to get it a lot easier than trying to use a table. So that's why we teach you multiple ways. Sometimes this is easier, sometimes the algebraic way is easier. All right, solving for x, being able to get x all by itself. I'm not going to work through any of these problems unless someone asks me to do it. So if you're viewing this video and you're not quite sure how to get these answers, send me an email, contact me in whatever way, and I will go over these problems for you. But here you see what the correct answers are. If you copied the problem and you've shown your work and you checked your work, right, check your solutions, you should know whether you got yours correct or not. So go back and look and see if you got some of these wrongs, where you might have made your mistake, and see if you can fix them, knowing that these are the correct answers. All right, here's another box plot. Kevin found the box plot below in the school newspaper. So what number of hours watching TV? So I'm going to mention a few things here, what I know. Some students didn't watch TV at all, while other students watched as much as 21 hours for the week. The median was 5 hours. I know that 50% of the students watched between 3 and 10 hours of TV. I know that only 25%, that's supposed to say percent, 25% here watched more than 10 hours. So I'm not even answering any questions yet. I'm just thinking about the problems, just thinking about the box plot and interpreting this box plot. Okay, so now let's read through some of the questions. And it looks like I've already addressed some of them. Based on the plot, what percent of students watch more than 10 hours of television? Well, that would be this sector right there. That's 25%, right? That watched more than 10 hours. That's what we said there. Based on the box plot, what percent of students watch less? Okay, so this is 25 and this is 25%. So watching less than 5 hours would have been 50%. And Kevin used the box plot to find the mean, or the average, of the hours of television that each student watched, and the answer is no, because once again, we don't know any of the individual data. The only individual data that we are guaranteed of knowing is the minimum. At least one person watched 0, and at least one person watched 21. But we don't know anything else, and we don't know how many people watched 0 and how many people watched 21. We just know those are the minimum and maximum. And solving equations that involve decimals and fractions. Remember, fraction busters or decimal busters. You don't have to do that. You could take 200 and divide it by 0.85 and get this answer with your calculator without any trouble at all. 200 divided by 0.85, and there is your solution, which I've rounded off. Did I round it properly? I think I did. Yeah, barely. You can justify rounding that to 235.3. If you wanted to do fraction busters because you didn't have a calculator handy, it might be handy to multiply everything times 100 and call that 85x is equal to 20,000. And maybe that's easier to do the division when you don't have the decimals in there. I think it is probably. Here, same kind of an idea. You could have just multiplied both sides times 6 over 7, because that's going to cancel everything out and make that 1x. And now you do 140 times 6 and then divide it by 7, and you get 120. But that's what you would do if you did fraction busters anyway. If you wanted to multiply both sides times 6, that would cancel this out, give you 7x is equal to, what is that, 840? I think so. Yeah, 840. And then when you divide each side by 7, then you end up getting your final answer. And that is it for homework for today. All right, so let's move on to the next activity. Take care. Take care.
Hey, feeling good, like I should. When in dark, walk